Have you ever watched something tumble through the air, maybe a wrench or a baseball bat, and thought, wow, that motion is just a complete mess? Well, what if I told you there's a hidden secret point in that object that's moving in a perfectly simple, totally predictable way? Today, we're pulling back the curtain on one of the coolest concepts in physics, the center of mass.
So to really get why this idea is so powerful, we first got to appreciate the problem it solves. Let's start with the chaos, right? Let's look at why the motion of just about any real-world object seems so complicated.
I mean, really think about it. If an object isn't just a tiny dot, if it's a big, clunky thing that's spinning and tumbling all over the place, how on earth are you supposed to describe its motion with any kind of simple rule? A baseball bat is the perfect example here. You toss it, and if you try to track the very tip of the bat, it's making this wild, loopy pattern. And the handle? It's doing something completely different. It seems like every single piece of that bat is on its own crazy, chaotic journey. You can't just treat the whole thing as one single point. Okay, but what if there was a way to just see right through all of that noise? Physics gives us this incredibly elegant tool, a sort of magic balance point that lets us completely ignore all the spinning and tumbling and just focus on one simple path. And here it is. This is the solution. Hidden somewhere in that flipping, spinning bat, there is one and only one special point that doesn't care about any of the rotation. It just sails smoothly through the air in a perfect parabola, exactly like you just tossed a tennis ball. And that special point? That's the center of mass.
So what is it, technically? Well, the center of mass, or COM for short, is the unique point where you can pretend the object's entire mass is concentrated. It's the average position of all the mass in the whole system. You can really just think of it as its perfect balance point.
Now, you've probably heard the term center of gravity thrown around too. So are they the same? Pretty much. The center of mass is about where the mass is, and the center of gravity is about where the weight is. Here on Earth, where gravity is nice and uniform, they're in the exact same spot. So for our chat today, you can basically use the terms interchangeably.
And this right here is why the concept is such a game changer. It lets us take these incredibly complex systems and make them simple. We can just follow this one little dot and treat all the outside forces, like gravity, as if they're pulling on that one single point. It's an amazing shortcut.
And here's a little fact that might bend your brain a bit. This point doesn't even have to be inside the actual object. For something like a donut or a wedding ring, the balance point, the center of mass, is floating right there in the empty space in the middle. Wild, right?
Okay, so this point is obviously super useful for simplifying motion. But how do we actually find it? Well, it turns out the math behind it all is way simpler than you might think.
Finding it is really just like calculating a weighted average, but instead of grades, we're using mass. All you do is take each piece of the system, multiply its mass by its location, add all of those products together, and then just divide the whole thing by the total mass. That's it.
Let's put some real numbers on that. Imagine you have a 3 kilogram weight sitting at position 0 and a 1 kilogram weight out of position 4. Okay, so we do the math. 3 times 0 is 0. 1 times 4 is 4. Add them up, you get 4. Now divide by the total mass, which is 3 plus 1, so 4 kilograms. The result? The center of mass is at the 1 meter mark.
And notice where that point ended up. It's not smack in the middle at 2 meters, it's at 1 meter, way closer to the heavier 3 kilogram mass. And that's a key takeaway, a great piece of intuition to have. The center of mass is always going to be pulled closer to wherever the most mass is.
So this is way more than just a trick for physics homework. The center of mass is a fundamental idea that you can see absolutely everywhere. It shapes everything from amazing athletic achievements to the design of cutting-edge technology.
A high jumper is such a great example. You've seen them arch their back into that U shape as they go over the bar. Why do they do that? It's genius. It allows their physical body to clear the bar while their center of mass actually sneaks right under it. Engineers use it to design cars that don't tip over. And you use it all the time without thinking, every time you lean to the side to balance a heavy bag of groceries.
All right, this all brings us to the grand finale. We're about to get to the single most important rule that governs the center of mass. This is the principle that really makes it one of the most powerful ideas in all of physics.
Here it is, the big rule. Internal forces, that is, forces that parts of a system exert on each other, can't change the motion of the system's center of mass.
period. Only an external force, a push or a pull from outside the system, can do that. Just picture two ice skaters standing still on perfectly smooth ice. They push off each other. What happens? They go flying apart in opposite directions. But, and this is the key, their combined center of mass doesn't move an inch. It stays right where it was. That push was a powerful force for sure, but it was internal to the two-skater system, so the overall COM just stays put.
And the consequence of this is just massive. It means that if you have a system just floating out in space with no outside forces messing with it, its center of mass will either stay perfectly still or move in a perfectly straight line at a constant speed forever. The system can't do anything on its own, it can't explode or wiggle or anything to change the path of its own center of mass.
So that leaves us with one final thought to chew on. From a chaotic firework explosion to the intricate dance of planets in a galaxy, the center of mass always follows a simple, predictable path, a path that only cares about forces from the outside. So, if all that internal chaos and complexity doesn't matter one bit to the center's motion, what does that tell us about finding the simple, elegant patterns that are hidden in the chaos all around us?